There is no universal industry standard for rough makeup. However, certain practices are widely accepted and recommended by electrical codes and organizations such as the National Electrical Code, also known as NEC, and the National Electrical Contractors Association, also known as NECA. The following rough makeup practices are commonly used in the industry. Firstly, conductors are typically taped together to prevent confusion and ensure proper connections. Secondly, travelers on three-way switches are typically twisted together and taped for identification. Thirdly, switch legs on single-pole switches are typically looped to provide a convenient connection point. Fourthly, circuit numbers are sometimes marked inside the electrical box for future reference. Fifthly, common conductors can be bundled together using electrical tape or a wire nut. Sixthly, line and load side connections on ground fault circuit interrupters, also known as GFCIs, are typically insulated from each other. The method that someone may have described is generally consistent with industry practices. However, the use of Romex sheath to create markers for each conductor is not a commonly accepted practice. While the suggestion of creating conductor markers may provide some additional clarity, it is important to consider the following. 1. Creating conductor markers can be time-consuming, especially in large or complex electrical systems. 2. Circuit numbers and other markings are typically already present on electrical devices and wires. 3. Conductors can be damaged if the sheath markers are improperly installed. In addition to the common practices mentioned above, other alternative methods for rough makeup include: firstly, different colors of electrical tape can be used to identify different circuits or conductors. Secondly, commercial marking tape can be used to label conductors with specific information. Thirdly, numbered wire connectors can be used to identify conductors in a specific order. While there is no universal industry standard for rough makeup, certain practices are widely accepted to ensure proper connections, prevent confusion, and comply with electrical codes. The method described is generally consistent with industry norms, and the suggestion of creating conductor markers is a matter of preference and should be considered based on the specific project and circumstances. In residential electrical wiring, several key components and practices ensure safety and functionality. Understanding these elements is crucial for anyone involved in electrical work, whether you are a seasoned professional or a homeowner undertaking a DIY project. One of the most fundamental aspects of electrical wiring is the proper identification and handling of conductors. Conductors are the wires that carry electrical current throughout a building. They are typically made of copper or aluminum due to their excellent conductivity. Each conductor is insulated with a colored plastic or rubber coating to prevent short circuits and ensure safety. In North America, the standard color code for conductors is as follows. Black or red wires are typically used for the hot or live wires that carry the electrical current from the power source to the devices or appliances. White or gray wires are used for the neutral wires, which return the current back to the power source. Green or bare copper wires are used for the ground wires, which provide a safe path for electrical current to flow in the event of a fault, preventing electrical shocks and fires. Proper grounding is essential for electrical safety. The ground wire is connected to a grounding electrode, such as a metal rod driven into the earth or a metal water pipe that is in contact with the earth. This grounding system provides a low resistance path for fault currents to flow back to the power source, tripping the circuit breaker or fuse and cutting off the power to the circuit. In addition to the basic conductors, there are also specialized conductors used in certain applications. For example, travelers are used in three-way and four-way switch circuits to control a light fixture from multiple locations. These travelers are typically identified by their color, often red or blue. Another important aspect of electrical wiring is the use of proper wiring methods. The National Electrical Code, or NEC, specifies the approved wiring methods for different types of buildings and occupancies. Some common wiring methods include non-metallic sheath cable, also known as NM cable or Romex, which is commonly used in residential wiring for branch circuits that supply power to lights, receptacles, and small appliances. Metallic conduit, such as electrical metallic tubing, also known as EMT, or rigid metal conduit, also known as RMC, which is used in commercial and industrial wiring for its durability and protection against physical damage. Armored cable, also known as AC cable or BX cable, which is used in both residential and commercial wiring for its flexibility and ease of installation. When installing electrical wiring, it is important to follow the NEC guidelines for wire sizing, overcurrent protection, and box fill. Wire sizing refers to the selection of the appropriate gauge of wire for the amount of current it will carry. The NEC provides tables that specify the ampacity or current carrying capacity of different wire sizes based on their insulation type and installation conditions. Overcurrent protection refers to the use of circuit breakers or fuses to protect the wiring from overheating and causing a fire in the event of an overload or short circuit. The NEC specifies the maximum overcurrent protection rating for different wire sizes and circuit types. Box fill refers to the amount of space available inside an electrical box for the wires, devices, and connectors. The NEC provides rules for calculating the box fill based on the number and size of the conductors and devices in the box. Proper box fill is essential to prevent overcrowding and damage to the wiring. In addition to the wiring itself, electrical boxes are an important component of the electrical system. Electrical boxes are used to enclose and protect the wiring connections and devices such as switches, receptacles, and lighting fixtures. Electrical boxes are typically made of metal or plastic and come in various sizes and shapes to accommodate different wiring configurations. The NEC specifies the types of electrical boxes that are permitted for different applications, as well as the requirements for their installation. Another key aspect of residential electrical wiring is the proper installation of devices such as switches, receptacles, and lighting fixtures. Switches are used to control the flow of electricity to lights and other devices. Receptacles, also known as outlets, provide a convenient way to plug in electrical appliances and devices. Lighting fixtures provide illumination for the home. When installing electrical devices, it is important to follow the manufacturer's instructions and the NEC guidelines for their installation. This includes ensuring that the devices are properly grounded, that the wiring connections are secure, and that the devices are securely mounted in the electrical box. In addition to the basic wiring and devices, there are also several specialized electrical systems that are commonly found in residential buildings. These include smoke detectors, which are designed to detect the presence of smoke and alert the occupants of a fire. Carbon monoxide detectors, which are designed to detect the presence of carbon monoxide gas, a colorless and odorless gas that can be deadly. Ground fault circuit interrupters, also known as GFCIs, which are designed to protect against electrical shocks by detecting ground faults and interrupting the circuit. Arc fault circuit interrupters, also known as FSIs, which are designed to protect against electrical fires by detecting arc faults, which are dangerous electrical discharges that can occur in damaged or worn wiring. Surge protectors, which are designed to protect electronic devices from voltage spikes and surges. These specialized electrical systems play an important role in ensuring the safety and well-being of the occupants of the building. The importance of proper electrical rough makeup is paramount. In electrical work, rough makeup refers to the initial stages of wiring an electrical system before the walls are finished. It involves installing electrical boxes, running wires, and making preliminary connections. Proper rough makeup is essential for ensuring the safety and functionality of the electrical system. Firstly, accurate planning and layout is needed. Before starting the rough makeup, it is important to have a detailed plan of the electrical system. This plan should include the location of all electrical boxes, switches, receptacles, and lighting fixtures. It should also specify the wiring methods and materials to be used. Accurate planning and layout will help to ensure that the electrical system is installed correctly and efficiently. Secondly, the proper box installation is needed. Electrical boxes should be securely mounted to the studs or framing members. They should be installed at the correct height and in the correct orientation. The NEC specifies the requirements for box mounting and support. Thirdly, the correct wire routing is needed. Wires should be run in a neat and orderly manner, following the shortest possible path between electrical boxes. Wires should be secured to the studs or framing members with cable staples or wire ties. The NEC specifies the requirements for wire routing and support. Fourthly, making secure connections is needed. Wiring connections should be made using approved methods, such as wire nuts or crimp connectors. Connections should be tight and secure to prevent loose connections, which can cause overheating and electrical fires. Fifthly, the proper grounding is needed. Grounding is essential for electrical safety. All electrical boxes, devices, and equipment should be properly grounded. The grounding system should be installed in accordance with the NEC guidelines. Sixthly, the protection of wires is needed. Wires should be protected from physical damage. This can be accomplished by running wires through conduit or using armored cable. Wires should also be protected from abrasion and sharp edges. Seventhly, the proper labeling is needed. All circuits should be labeled with their corresponding circuit breaker or fuse number. This will help to identify the correct circuit in the event of a problem. Eighthly, the inspection is needed. The electrical rough makeup should be inspected by a qualified electrical inspector before the walls are closed up. The inspector will verify that the electrical system has been installed in accordance with the NEC and local codes. Proper electrical rough makeup is essential for ensuring the safety and functionality of the electrical system. By following these guidelines, electricians and homeowners can help to prevent electrical shocks, fires, and other hazards. Now let us explore some important things to remember regarding safety. Electrical work can be dangerous if not performed correctly. It is important to take the necessary safety precautions to prevent electrical shocks, fires, and other hazards. Some important safety precautions include, firstly, always turning off the power before working on electrical circuits. This can be accomplished by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Secondly, using insulated tools when working on electrical circuits. Insulated tools will help to protect you from electrical shocks. Thirdly, wearing safety glasses to protect your eyes from flying debris. Fourthly, wearing rubber gloves to protect your hands from electrical shocks. Fifthly, never working on electrical circuits when you are wet or standing in water. Sixthly, never overloading electrical circuits. Overloading can cause the wires to overheat and start a fire. Seventhly, never tampering with electrical wiring or equipment. Tampering can create a dangerous situation. Eighthly, always calling a qualified electrician to perform electrical work that you are not comfortable doing. By following these safety precautions, you can help to prevent electrical shocks, fires, and other hazards. And lastly, here are some more points to remember. Here are some additional points to keep in mind when working with electrical wiring. Firstly, always follow the NEC and local electrical codes. Secondly, obtain any necessary permits before starting electrical work. Thirdly, use only approved electrical materials and equipment. Fourthly, make sure all wiring connections are tight and secure. Fifthly, protect wires from physical damage. Sixthly, ground all electrical boxes, devices, and equipment. Seventhly, label all circuits with their corresponding circuit breaker or fuse number. Eighthly, have the electrical work inspected by a qualified electrical inspector. By following these guidelines, you can help to ensure that the electrical system is installed correctly and safely. The role of electrical inspections is very important. Electrical inspections are an important part of ensuring the safety and compliance of electrical installations. Electrical inspections are typically performed by qualified electrical inspectors who are employed by local governments or third-party inspection agencies. The purpose of an electrical inspection is to verify that the electrical system has been installed in accordance with the NEC and local electrical codes. The electrical inspector will examine the wiring, devices, and equipment to ensure that they are properly installed, grounded, and protected. The electrical inspector will also check for any potential hazards such as exposed wiring, loose connections, or overloaded circuits. If the electrical inspector finds any violations of the electrical codes, They will issue a notice of violation which must be corrected before the electrical system can be approved. Electrical inspections are typically required for new construction, renovations, and additions to existing buildings. They may also be required when there is a change in occupancy or when there is a reported electrical hazard. Electrical inspections play an important role in preventing electrical shocks, fires, and other hazards. By ensuring that electrical systems are installed in accordance with the electrical codes, electrical inspections help to protect the safety of building occupants and the public. Here are some specific items that are typically inspected during an electrical inspection. Firstly, the grounding system. The electrical inspector will verify that the grounding system is properly installed and that all electrical boxes, devices, and equipment are properly grounded. Secondly, the wiring methods. The electrical inspector will verify that the wiring methods used are approved for the type of building and occupancy. They will also check to ensure that the wires are properly sized, supported, and protected from physical damage. Thirdly, the overcurrent protection. The electrical inspector will verify that the circuit breakers or fuses are the correct size for the circuits they protect. They will also check to ensure that the overcurrent protection devices are properly labeled. Fourthly, the electrical boxes. The electrical inspector will verify that the electrical boxes are properly sized and installed. They will also check to ensure that the boxes are not overcrowded with wires. Fifthly, the devices and equipment. The electrical inspector will verify that the electrical devices and equipment are properly installed and that they are in good working condition. They will also check to ensure that the devices and equipment are properly labeled. Sixthly, the smoke detectors and carbon monoxide detectors. The electrical inspector will verify that the smoke detectors and carbon monoxide detectors are properly installed and that they are in good working condition. Seventhly, the ground fault circuit interrupters, also known as GFCIs, and arc fault circuit interrupters, also known as FCIs. The electrical inspector will verify that the ground fault circuit interrupters and arc fault circuit interrupters are properly installed and that they are functioning correctly. If the electrical inspector finds any violations of the electrical codes, they will issue a notice of violation, which must be corrected before the electrical system can be approved. It is important to correct any violations promptly to ensure the safety of the electrical system. Electrical inspections are an important part of ensuring the safety and compliance of electrical installations. By having your electrical system inspected by a qualified electrical inspector, you can help to protect your home or business from electrical hazards.